Hello friends, in this session we will study the concept of game playing techniques. Game playing it is an important domain of artificial intelligence. Game doesn't require much knowledge. The only knowledge we need to provide is the rules, legal moves, and the condition of winning or losing the games. In game playing, both players tries to win the game. So both of them try to make the best move possible at each turns. Searching techniques like BFS or we can say breadth first search are not accurate for this as the branching factor. For that, branching factor in the BFS is very high. So searching will take a lot of time. So we need another search procedure that improve generate procedure so that only good moves are generated. And next is the test procedure so that the best move can be explored first. So now I start this session with the help of alpha beta pruning. Alpha beta pruning is a modified version of the minimax algorithm. It is an optimization technique for the min-max algorithm. As we have seen in the minimax search algorithm that the number of game states is to examine are exponential in depth of the tree. Since we cannot eliminate the exponent, but we can cut it to halves. Hence, that is a technique by which, without checking each node of the game tree, we can compute the correct minimax decision. And this technique is called pruning. This involves two thresholds parameter. One is alpha and second is beta for further expansions. So it is called alpha beta pruning, or it is also called alpha beta algorithm. Now, alpha beta pruning can be applied at any depth of the tree, and sometimes it not only prune the tree leaves but also entire subtree. So, with the help of alpha beta pruning, we can get best results compared to min-max algorithm. Now, in the alpha beta pruning, the two parameters can be defined. Like first is alpha, means the best or we can say highest value choice we have found so far at any point along the path of the maximizer. The initial value of alpha is minus infinity. And next is beta. The best or we can say lowest value choice we have found so far at any point along the path of the minimizer. The initial value of beta is plus infinity. The alpha beta pruning to a standard min-max algorithm returns the same moves as the standard algorithms, but it removes all the nodes which are not really affecting the final decisions, but making algorithm slower. So for that, by pruning these nodes, it makes the algorithm faster. So for that, condition for alpha beta pruning is that the main condition which required for alpha beta pruning is alpha greater than or equal to beta. Now we have seen the key points about alpha beta pruning. The first is the max player will only update the value of alpha. So max player is the only one which can change the value of alpha. Next is the mean player will only update the value of beta. So with the help of the mean player can change the value of beta. Now While backtracking the tree, the node value will be passed to upper node instead of the value of alpha and beta. And we will only pass the alpha and beta value to the child nodes. Now we have seen the working of alpha beta pruning. Now we have taken example of two-player search tree to understand the working of alpha beta pruning. So in step 1, at the first steps, the max player will start first move of the node A, or where A is initialized by alpha is equal to minus infinity and beta is equal to plus infinity. So here A has the two value. For the A, max value is alpha is equal to minus infinity and mean value for beta is equal to plus infinity. This value of alpha and beta pass down to node B, where again alpha is equal to minus infinity and beta is equal to plus infinity. And node B pass the value to the child node D. Now we have seen that step number 2. At the node D, the value of alpha will be calculated as its turn of max. So the value of alpha is compared with first 2 and then 3, and the max is equal to 2 and 3 is equal to max value is equal to 3. We will be the value of alpha at the node D and the node value will also 3. So in step number 2, we have find out the value of node D. Now in step 3, now algorithm backtrack to node B, where the value of beta will change as this is a turn of mean. So now beta is equal to plus infinity. We'll compare with the available subsequent node value. Example like, so for mean of plus infinity and 3. So mean value is equal to 3. Hence at the node B, now alpha is equal to minus infinity and beta is equal to 3. In next steps, the algorithm traverses the next successor of node B, which is node E. And the value of alpha is equal to minus infinity and beta is equal to 3 will also be passed. So this value is passed in the step number 4. So now in step 4 at the node E, max will take its turn and the value of alpha will change. The current value of alpha will be compared with 5. So max minus infinity and 5. So answer is 5. Hence the 8. Hence at the node E, alpha value is 5 and beta value is 3, where we have seen the condition like alpha is greater than or equal to beta. So that right successor of E will be pruned and algorithm will not traverse it and the value of node E will be 5. Now we have seen the step number 5. At the next steps, algorithm again backtrack the tree from node B to node A. At the end of A, the value of alpha will be changed. The maximum available value is 3 and the max is passed minus infinitive and 3 value. So we have select the maximum value is 3 and beta is plus infinitive. These two value now pass to the right successor of A, which is node C. So at the node C, alpha is equal to 3 and beta is equal to plus infinitive. And the same value will be passed to the node F. Now we have seen the step number 6 at the node F. The value of alpha will be compared with lift child, which is 0, and max is 3, 0. So maximum value is 3, and then compare with right child, which is 1, and max 3, 1. So we have select the maximum value 3. Still alpha remaining 3, but the node value of F will become 1. Now we have see the step number 7. For that, node F returns the node value 1 to the node C. At the C, alpha is equal to 3 and beta is equal to plus infinitive. Hence, the value of beta will be changed. It will compare with 1. So, minimum value is plus infinitive and 1. So, answer is 1. Now, C, alpha is equal to 3 and beta is equal to 1. And again, it satisfies the condition alpha greater than is equal to beta. So the next child of C, which is G, will be pruned and the algorithm will not compute the entire subtree G. So now in step 8, C now turns the value of 1 to A. Hence the best value of A is max 3, 1. So answer is 3. Following is the final game tree, which is the solution, the node which are computed and nodes which has never computed. Hence the optimal value of maximizer is 3 for this example. So this way we have seen the alpha beta pruning algorithm working process. So I hope you can understand the working process of alpha beta pruning. Now we have seen the move order in alpha beta pruning. The effectiveness of alpha beta pruning is highly dependent on the order in which each node is examined. Move order is an important aspect of alpha beta pruning. It can be a two types. First is worst ordering. In some case, alpha beta pruning algorithm does not prune any of the leaves of the tree and works exactly as min-max algorithm. In this case, it also consumes more time because of alpha beta factors, such as move of pruning is called worst ordering. In this case, the best move occurs on the right side of the tree. The time complexity of such an order is time complexity O belongs to B raised to M. So, next is ideal ordering. The ideal ordering of alpha beta pruning occurs when loss of pruning happens in the tree. The base moves occurs at the left side of the tree. We apply DFS, hence its first search left of the tree and go deep twice as min-max algorithm in the same amount of time. Complexity in ideal ordering is O belongs to B raised to M divided by 2. Now we have seen the rules to find good ordering. So here we have discussed some rules to find good ordering in alpha beta pruning. First is occurs the best move from the shallowest node. Next is order the nodes in the tree such that the best nodes are checked first. Use domain knowledge while finding the best move. Like example for chess, to try order, compute first, then threads, then forward moves, then backwards moves. Now we can bookkeep the states, means as there is a possibilities that states may repeats. So I hope you can understand the alpha beta pruning. So thank you friends watching this video. I hope you can understand all the concept of alpha beta pruning in game theory for artificial intelligence. Thank you.